All right, welcome. This is the last video I have for our week 2 material, and we're going to talk about the complex number system. Basically, complex numbers are a way to deal with the square root or the fourth root or whatever of a negative. What you need to remember is that the square root of -1 is I. And I is just the symbol we use to represent imaginary numbers. In other words, the fact that we do have the square root of a negative. This is an easier way to see it instead of all that writing I just had in front of you. So the square root of -1 is I, and you'll also need to know that I squared is -1. Because if I square both sides, that's what we would get. Okay? So if you had something like the square root of -p, that would just be the same thing as the square root of -1 times the square root of p, and we know that the square root of -1 is I, and so our answer would be I times the square root of p. This is the better way to write it. Writing square root of p times I, as you see to the right, is okay, but it's not as clear what's under the square root symbol. Okay, so putting I out front just makes it a little bit easier to see. Okay, so if you had the square root of -9, it would be the same thing as the square root of -1 times the square root of 9, which is 3i. Or I times 3, I think it's better form to put the number first. Okay, and then b, the negative square root of -48. Remember that negative in front isn't under the radical, so that's perfectly fine. So what we have is -4i times the square root of 3. Because 48 is 16 times 3. I can take the square root of 16 and get 4. Can't do anything with the 3, so that stays under the radical. The -1 comes out too because I know that the square root of -1 is I. Okay, so an imaginary number can be written in the form of a plus bi. For example, you could have like 5 plus 7i, something like that. Okay. So a complex number is in that form, and either A or B could be 0. Okay, I'm going to show you a cool little graphic here. This shows you don't have to memorize this probably ever, but it's a neat little graphic that shows where all of the numbers come into play, because the complex numbers encompass everything. Okay, because as you can see on that list at the end, 5 is a complex number. Who would have thought? But the reason that's complex is because we can write that as 5 plus 0i, okay? But imaginary numbers are such to where that bi part, b is not 0. In other words, you do have that I component. That's what makes it imaginary, okay? And real is where you do have that number being 0. So there is no I component. But you don't have to memorize this. I just thought it was really cool to see how everything fits together. And I just think it's neat to see how far you've come from learning just rational numbers, positives, negatives, and fractions. Now you're all the way up to the top. You've learned them all. All right, so we can add or subtract anything as long as we combine like terms. Okay, and that hasn't changed. So if you look at example A, 3 plus 2i plus 7 plus 8i, well, I can add the 3 and the 7 because those are like terms, and I get 10. And I could add the 2i and the 8i and get 10i, and those are like terms, and that's it. And multiplication, I don't have to worry about like terms, do I? If I have square root of -6 times square root of -5, that's the same thing as I times the square root of 6 times I times the square root of 5, which is I squared times square root of 30, and this is where mistakes happen. Don't stop there. So I don't blame you if you got to this step and you're happy. I want you to be happy. That's good. You've done a lot. But just remember, I squared is equal to -1, so we can simplify this expression right here. All right, this seems logical. Writing square root of -3 times square root of -5 equals square root of positive 15. That looks right, but that's incorrect, and I want you to be really careful about that, because these have imaginary numbers as part of their radical expressions before we start. We can't just remove the fact that these are imaginary. So the first number is really I times the square root of 3, and the second is really I times the square root of 5. We've got to have that I component. Then we can simplify from there. All right, like you see in example A, and really like the example we did a couple of seconds ago. That's really I times square root of 2 times I times square root of 10, which is I squared times the square root of 20. All right, now 20 is 4 times 5, right? We can take the square root of 4. The square root of 4 is 2, so we can pull that out. The 5 stays in, and that's how we ended up with negative 2 times square root of 5. All right, so example B, how would you work with that? Well, I would just distribute 2I to each term and then simplify. Just remember that you're not finished with these problems if you have an I squared in your answer. Remember, I squared is negative 1, so you need to take care of that. C is actually something we'll deal with next week, so don't worry about that. You won't see that one. And it's just an interesting thing that the conjugate is just, if you have A plus BI, the conjugate is A minus BI. Here's some examples of that, and some examples of how that would help you with division. Okay, but you're really going to work with this type of concept later, so don't worry about that for right now. And simplifying powers of I is actually kind of cool because it looks like I to the 23rd power. There's no way we can get that. We don't have enough information. And really we do, because I can write that as I to the 2nd time to the 11th times I to the 1st, because I to the 2nd to the 11th is I to the 22nd. We just need one more. So since I to the 2nd is negative 1 and negative 1 to the 11th is negative 1, my final answer would be negative I, interestingly enough. So in the PowerPoint presentation and doc sharing, you're going to see a ton of other examples just like it. So that's all I have for week 2. If you have any questions, make sure you ask me, and thank you for watching this video.